Hello everybody. Today we are talking about independent and dependent events. Wilma's here to join us. Say hello, Wilma. Hello. So far we have talked about simple probability. We've talked about compound probability. What we're talking about today is another type of compound probability, meaning more than one event is happening. So this will just break it down a little bit more. We have used fundamental counting principle. We have drawn tree diagrams and found sample spaces. Those are all about compound probability. But now we're actually going to figure out the fraction probability for those type of problems. So we have two different things. Independence. If you are independent, you are alone. You're on your own. Independent events describe two or more events in which one event does not affect the outcome of the other. One event does not, emphasize the not, affect, with an A, the outcome of another. And we'll see plenty of examples of those. So dependent, if you're dependent, you rely on someone. They affect you. They help you. Dependent events are events in which the outcome of one event does affect the outcome of another. So the outcome of one event affects another outcome. So, an example of independent events. There are 10 marbles in a bag. Imagine that. 5 are red and 5 are blue. You choose one marble and return it to the bag. Doesn't that sound like when we were working with M&Ms and Skittles? Choose another marble and return it to the bag. The probability of choosing a red marble is the same on each draw because you returned them. So here's how we do independent events. The probability of picking a red was 5 out of a total of 10. And when we have compound events, we multiply the probabilities together. So the second pick, I still have a 5 out of 10 chance of picking a red. That hasn't changed. And we would multiply these and simplify. So I would have a 1/4 chance of picking red the first time and red the second time. Alternatively, if you choose one marble and did not return it to the bag before you chose the second one, then you have affected the results of the second draw. The probability of choosing a red on the second draw would be dependent on the results of the first draw. So let's see how that changes our answer. On our first pick, it's the same. There's always 5 out of 10 to start. However, now we assume that we've gotten the red one that we wanted. So now there's only 4 left in the bag. But also I took one out, so now there's only a total of 9. So the first fraction remains the same, but the second one has changed, both the numerator and the denominator. Now, we always simplify. So you could simplify from here. 5/10 is 1/2. We could simplify some more. 2 goes into 2 once, goes into 4 twice, and our final answer would be 2/9. Moving on with some more examples. So first, some independent events, 2 things that do not affect each other. There are 2 spinners to the right. One of them has numbers, one of them has letters. And let's begin. Number 1, what's the probability of spinning a 4? So there is 1 4 out of a total of 8 numbers, so 1/8 chance, times, what's the probability of spinning a C? There are how many C's out of the total? 1 C out of 6. And multiply. So a reminder, when we multiply, we go straight across. Easiest one, you do not find a common denominator. Numerator times numerator, denominator times denominator. So this ends up being a pretty small chance, 1/48 chance of both of those occurring. Let's try number 2, probability of spinning a 1. Again, there is 1 1 out of 8 total numbers, times, how many A's are there? 3 out of 6. So I'm going to write my original fractions before I reduce them. Now I can reduce this to 1/2. Multiply straight across, get 1/16. Number 3, what's the probability of spinning an even? Well, how many numbers out of those 8 are even? Half of them, so 4/8. And how many C's do we have? 1 out of 6. Go ahead and simplify. Remember, when you simplify, you can do any numerator with any denominator. So I'm just deciding to reduce the first fraction by itself. Number 4, probability of spinning an odd. Well, that's the same as spinning an even. 4 out of 8 are odd. And how many A's do we have? Half of them, 3 out of 6. Again, I'm just going to write my original fractions first before I simplify. Ends up being 1/2 times 1/2 is 1/4, multiplying straight across. Let's do 2 more of these independent. How many of these numbers are greater than 3? And how many B's do we have? So I hope you start doing these on your own and not just copying. You can figure those out for yourself. You can do some simplifying. And I get 5/24 as my answer. Pause the video, do number 6 on your own, then come back and check if we got the same answer. For number 6, how many are less than 5? That would be 4 of them. And how many B's do we have? 1 out of 6. Final answer, 1/12. Is that right? Let me double check. How many B's? Oh, I counted wrong. Sorry, 2 B's. This reduces to 1/3. I'm sorry, final answer, 1/6. Tricked ya, haha. Did you catch it? Moving on. Dependent events, where one event does affect the outcome of the second. So let's read this scenario carefully. There are 10 yellows, 6 greens, 9 oranges, and 5 red cards in a stack of cards turned face down. Once a card is selected, it is not replaced. You're always looking for that not word to help you figure out your problem. Find each probability. So, number 7, the probability of picking 2 yellow cards. How many yellows do I have? I have 10 out of a total of how many? So let's take a moment and add these all up. 10 plus 6, 16, plus 9 is 25, plus 5 more is 30. So I have a total of 30. I'm going to need that number, I know, for many of these problems, for all of them. So I have 10 out of 30 yellows. Now, 1 was taken out, so now I only have 9 yellows left in the deck, and I also only have a total of 29 cards left total. So we're going to be working with some big numbers here, so I hope we have some simplifying that can take place. I do. 10 over 30 reduces to 1/3. I can also cross-cancel. 3 goes into 3 once, goes into 9 3 times. Multiply across, final answer, 3/29. So let's try another one of those. Very similar. What's the probability of picking 2 green cards? I start with 6 out of 30. But I always assume that I get what I wanted, so I took out that 1 green card. Now there's only 5 left in the deck. And there's also only a total of 29 left in the deck. So we'll notice a lot of similarities as we keep doing some of these card problems. Start with 30, take out 1, so now I only have 29. Let's do a lot of cross-canceling here. Simplifying. Only 1 out of 29 chance of that happening. Pretty soon you're going to be doing some of these on your own, but let's do a couple more together. Number 9, probability of picking a yellow card and then a green card. So we did this before. First I have 10 out of 30 yellow cards. I got what I wanted. Take out that yellow card. How many greens are there? There were 6 greens out of 29 because we took that one out. Go ahead and simplify. Two out of 29 chance. And anytime if I'm going too fast, pause the video, work it out yourself, and then check if we got the same thing. One more of these. Probability of getting a red card. So I started with 5 red cards out of a total of 30. Took that one out. Then I got an orange card, or I'm hoping for an orange card. There's 9 of those out of 29. So every single time in these 4 problems so far, start with 30, took one out, now I have 29. Start with 30, took one out, now I have 29. Go ahead and simplify. Three out of 58. So I'm going to ask you to do these next 2 problems on your own, and when we come into class, we will check those and see how you did. I'm confident you'll do fine. Pause the video and do those, please, and then join me on the back side of the paper for a couple of different problems. So expect problems like this when you have a quiz or a test. You have to decide on your own whether these events below are independent or dependent, and then you can answer them as a percent or a decimal. So first example, office supplies. A store sells a box of highlighters that contains 4 yellow, 3 blue, 2 pink, and 1 green highlighter. What's the probability of randomly picking first 1 blue and then 1 pink highlighter from the box? So we have to look at this problem carefully. Does it tell us that we are taking something out and replacing it? It does not say that. So we're going to assume we're taking out the blue and not putting it back, and then taking out a pink. So this would be dependent, because we're taking out one of the total. So it is affecting, taking out the blue is affecting the probability of picking the pink for the second one. So let's go ahead. How many blues do I have? 3 out of a total of how many? 4 plus 3 plus 2 plus 1 is 10. I got a blue. Now I'm picking a pink. There's 2 out of a total of 9 since we took one out. Can do some cross canceling. Do some more cross canceling. I get a final simplified answer of 1/15. Remember, you don't have to cross cancel, but at the end you always have to make sure that you're simplifying. Let's try this next one. Those of you who play basketball, I'd be really curious to know if you know this about yourself. Angelina makes 70% of her free throws. What's the probability that she will make her next 2 free throws? So you could figure this out for yourself. If you threw 100 free throws and counted up how many of them did you actually make. And try that a few times over the course of several days and find the average. So anyways, is this independent or dependent? When she makes 1 free throw, does it affect the results or the probability of her making the next one? No, it does not. So this is independent. So to figure out this one, we have to remember that percent means what? A number out of 100. So 70% means 70 over 100. So this would be her probability of making her first one. It's also the probability of her making the second one out of 100. You complete this answer. Make sure it's simplified. What are the chances that she would make her next 2 free throws? And finally, a couple more questions below. This is about car rentals. Use the following information and the information in the table. At a car rental office, 63% of the customers are men and 37% are women. Part A, what's the probability that the next customer will be a woman who requests a convertible? So a reminder, this is compound because we're being asked 2 different things. First of all, what's the probability that a woman comes up next? And then that woman chooses a convertible. So first thing is, what's the probability that a woman will come next? Well, 37% of customers are women. So as a fraction, that would be 37 out of 100. Now what's the chance or probability that she will request a convertible? Take a look at the table. That would be 10% chance. 10% is 10 out of 100. And you complete. We'll check the answers in class. Part B. What's the probability that the next customer will be a man who requests either a compact car or a luxury car? So how many of these customers are men? 63%, 63 out of 100. And let's go to the table. What's the chance that he chooses a compact car or a luxury car? So compact is 25% and luxury is 12. What am I going to have to do with those 2%? I'm going to have to add those together. So 25 plus 12% is 37%. So written as a fraction, 37 out of 100. I don't know if there's any cross-canceling possible. This might be a big number. You figure it out. All these circles that I have, please have them completed when you come to class and we'll check. Thanks for joining me. Say goodbye, Wilma. Bye.